Hi everyone, my name is Mendelos Kanakis, and today I'll be presenting our paper titled Efficient Visual Tracking with Exemplar Transformers. Specifically in this work, we are interested in the task of single object visual tracking. Given an initial frame and a bounding box indicating the object we're interested in tracking, we aim to track that object throughout the frames of the video. Motivation to this work. So more complex and powerful neural networks have advanced the state-of-the-art in visual object tracking, and specifically transformers. However, efficient tracking architectures have received surprisingly little attention, with some recent efforts aiming to close that performance gap. In this work, we ask ourselves, can we close the performance gap even further using transformers, however without compromising on the runtime? To this, we revisit the scale.product attention. As a recap, the self-attention computes a similarity score between all spatial locations, and then linearly combines the features across the entire sequences given those similarity scores. Here, we hypothesize that direct connection between all features can be suboptimal, and explicitly for single object tracking, a single instance level attention layer is sufficient. Specifically, we design a single instance level attention layer which requires a single global query token. For keys, we replace the reliance on solely intra-sample relationships with a small set of exemplar representations. Exemplar representations encapsulate the dataset information and dynamically adapt the attention layer given the global query token. And finally, values are jointly optimized with the keys and refine the input representation on the local level through a convolutional operation. Exemplar transformer layers can act as drop-in replacements for convolutional models, and they can be incorporated into any tracking architecture. In this work, we evaluate its efficacy on lightweight Siamese trackers. Recall back the previous performance plot, with LTE mobile shown on the right. We can replace a convolutional operation with our exemplar transformer layer, and this improves the performance by 7% with almost no degradation in runtime, and therefore still running up to 8 times faster than other transformer layers. When looking at the results, ET-Track outperforms competing real-time methods, shown in warm colors, while significantly closes the performance gap to more expensive transformers for tracking, shown in cold colors. Furthermore, it consistently outperforms other transformer layers. To conclude, we propose a novel transformer layer for single object visual tracking based on exemplar attention. Exemplar attention utilizes a single query token of the input sequence and jointly learns a small set of exemplar representations. The exemplar transformer layer can act as a substitute for a convolutional layer, and therefore ET-Track, our Siamese tracker, significantly improves the performance compared to the alternatives and runs in real time on computationally limited devices, such as the CPU. Thank you for your attention. For more details, please check out our paper.